In this video, we're going to talk about a concept called average velocity. And this is going to build on the topic we talked about earlier, that was displacement. And displacement, we found out, was just our final position minus our starting position. It didn't matter what path we took to get from one position to the other. All that mattered was the starting location and ending location, and we also needed to have a direction. Well, velocity builds on that. If you remember, average displacement was delta S. And then we took our final position minus our initial position, or S2 sometimes minus S1. Well, if we know the time it took for that to happen, let's just say our trip from Green Bay to La Crosse took us 4 hours. Well, now that we know that, we can turn this into a rate. And remember, rates are things that tell us how things change over time. So if we know our distance, change in distance, divided by our change in time, we are going to call that our average velocity. So average velocity in this case would be 210 miles minus 0, because that's what we started at, divided by 4 hours, and it ends up being 52.5 miles per hour. Now that does not mean we always were traveling 52.5 miles per hour. That's the average. I mean, sometimes we were traveling more than that. Other times we were probably traveling much less than that, possibly stopped, because we, don't just drive on one straight stretch of highway that does the exact same speed the entire time. We either have to slow down to go off ramps and stuff like that. So this is just an average speed. It tells us about what we went. And obviously this is a pretty good speed because it was pretty close to what the speed limit is. Even if it was a 65-mile-an-hour speed limit, we're still not too far below that. This is simply just a scalar at this point. This would be what we would refer to as our speed. Then if we would add something like a direction, for example, we put west after this, now this average velocity becomes a vector. And that really isn't too hard to understand. That says for every hour we traveled, we will have a displacement of 52.5 kilometers in the western direction. So that kind of divides us up into 4 equal parts. At each one of these intervals, we traveled about 52.5 miles going to the west. And average speed is really just that. It's kind of taking your total distance. Another way of thinking about this, I guess, your average velocity is really just equal to the total distance, or total displacement, divided by your total time. And what will happen is maybe we stop somewhere. Maybe, halfway somewhere along the road we stopped and we pulled into a McDonald's and we had some lunch. Well, that adds on to our total time, but it doesn't add on to our displacement. So what that would do is drop our average velocity and make that become lower and lower. So you have to remember that your change in time is your total time. Many times starting from 0. So sometimes you'll see this kind of written as like V average is equal to delta S divided by T. That's when T starts from 0 and basically says that, okay, you only need to know about your final time. Let's go through one more example. And I'm going to change colors to do this because I don't want to have the same colors in my text. And this is saying that Mary is running 100 meters in 20 seconds. And then she ran another 200 meters in 30 seconds. And I guess what our question is what is our average speed going to be for this example? So we can look at 3 different parts the way this is kind of set up. We could look at our average speed for the first 20 seconds. So 1 to 20, change in displacement over time. Let's make this change in time. So it's going to be 100 meters minus 0 meters divided by 20 seconds minus 0 seconds. And that turns out to be 5 meters per second. Now, we don't have a direction here. They didn't really give us one. So this is really just our average speed. It's not really our average velocity. Then what we can do is say, okay, well, what happened in the second? And we should intuitively know that, well, she traveled twice the distance in 1.5 the time. So from 20 to 50 seconds, V 20 to 50, this should have a higher just average velocity. So delta S over delta T again. And this is where the delta T is a little more important. We have to remember that we're going 50, we'll do that part first this time, 50 seconds minus 20 seconds, which gives us a total of 30 seconds. And I guess they got to be a little bit careful because a lot of times people, I guess you could just put in this 30 seconds the way it is underneath here. Don't make the mistake of thinking that's 30 minus 20, putting 10 seconds down here. That would give us a really different speed. But she traveled basically 200 more meters, so I could put that up here, or I could do 300 meters, which is her final distance, minus 100, which is where she started this new speed. So I end up with basically 200 meters divided by 30 seconds, which is going to give me a speed of 6.7 meters per second. So, and that should make sense. Like we said, we covered twice as much distance, but only had 1.5, had more 1.5 times the time that we did for the first 100 meters. So what if we wanted to know what happens in our entire trip? Well, we should expect that to be somewhere in between these two things. So let's just go V from 1 to 50. And again, it's delta S over delta T. So we're going to say, okay, our final thing was 300 meters minus 0 meters divided by the time, which in this case would be 50 seconds minus 0 seconds. And when you take 300 divided by 50, which is really the same as 30 divided by 5, that's going to be 6 meters per second, which kind of falls with our little prediction of saying that these two speeds, here's our high speed, here's our low speed, our average speed should be somewhere in between that. So the thing we want to remember is when you're doing average velocity, make sure you know what time interval you're doing. And basically always comes down to total distance over total time. And this one in the middle is the one that could be the tricky one at times. We ended up at 300 meters. We started that pace or that speed when we reached the 100-meter mark, so we took 300 minus 100. It did say we ran another 200 meters total, so I guess we could have put 200 meters, and you can kind of see that right here. So again, that's average velocity. It's a relatively simple concept. If we wanted to make these into vectors, maybe if Mary was running to the east, we would add east to all these, and then now these are considered vectors and not scalars. So that's our average velocity.